Designing electronic circuitry and systems requires many steps, from component specification to schematic diagram generation. Production of circuit boards that function according to the design rules associated with the system objectives is the goal. A printed circuit board can be developed for use with through-hole components or surface mount devices. In some cases, both types of components can be combined on the same printed circuit board. In this issue of NFDL, we will examine the process of designing a very small printed circuit board with surface mount technology. The manufacturers of electronic components produce resistors, capacitors, diodes, inductors, transistors, and many other parts with wire leads for through-hole and without wire leads for surface mount applications. The components in this photograph illustrate the difference. To the left of the dime, a NPN transistor with leads, and the surface mount equivalent part below. To the right of the dime, a dual inline integrated circuit, and the same part in a surface mount package. The blue-colored part is an electrolytic capacitor with wire leads, and the surface mount part is to the right of it. The enlarged view of the printed circuit board design indicates the location of surface mount parts in blue, and the copper circuit pattern is black. The circuit board material is copper-clad epoxy fiberglass. The circuit pattern is formed by producing a negative photo tool from the original artwork on transparent film. A photosensitive etch resist is applied to the copper layer, and the photo tool negative is contact printed by exposing the etch resist to ultraviolet light in the areas where the circuit pattern will be copper. The etch resist is developed, which washes away resist in the areas that were not exposed to ultraviolet. The board is then etched in a solution that dissolves away the copper not protected by the resist pattern. The printed circuit board is cleaned to remove resist from the copper. The parts are placed on the board in exactly the correct locations and soldered in place. This results in a functional circuit that can be interconnected with other printed circuit boards and components to form the completed system.